Now this is the table, and we have to plot this on this graph grid. Although this is supposed to be one big box and there are 10 small boxes, I'm sorry I'm unable to show these 10 small boxes on this board, but I will be showing when I will be doing the practicals. I will do something to show all those boxes here also, but for time being I'm not I'm sorry I'm unable to show those 10 boxes, but these 10 boxes are like this one here. So let us see how I can plot this one. This serial number, length in meters. I have ignored all other things, and here t square and second square. This is in 3 significant figures. These are all suppose in 4 significant figures. Nothing to do with my rules here. Now I have to plot L. I have to plot t square against L. T square against L means t square must be along y-axis and L must be along x-axis. The first rule is I will just label the axis. This I will label as L in meters, and this one as t square and second square. And I will get 1 mark because labeling is always 1 mark. Then I have to set the scale along x-axis. Scale along x-axis, I will start from 0.200. 0.200 starting point. Now what is the scale? How I scale? I will take maximum minus minimum. I will take this as 0.800 minus 0.200 divided by 8. How much comes out to be? I have to check it with the calculator. 0.8 minus 0.2 divided by 8. It is coming at 0.075. It's coming 0.075. This is 75. So 75, if you remember the numbers 1, 2, 4, 5, 10, 50, 10, 20, 25, 40, 50, 100 and 200. So 75 comes here. So I will take a scale of 100 in whole numbers. 100 in whole numbers will be the 3 decimal places 1, 2, 3. So 0.1 is the scale. I will take 0.2, this is 0.300, 0.400, 0.500, 0.600, 0.700, 0.800, and how many boxes are coming? 1, 2, 3, 4, 5, 6, 7 boxes are covered. 6 boxes are, it's okay. So it is almost 3 or 4, and 75% is covered for the x-axis. Now the scale of 1 big box is 0.1. So scale of 1 small box for this box, which I have shown in 1, this will be 0.01. I will write this here for my easy calculation later on. So this is the scale along x-axis. Now I will set the scale along y-axis, and I'll always label these things. Now scale along y-axis, I have to start y-axis 0.8060. So I can just take 0.8060, or I can start from 0.8. It is better to start somewhat little with 1 significant figure so that you can write the values then clearly. Now this is 3.224 minus 0.8 divided by 12. So it coming out to be 3.224 minus 0.8, this one, and divided by 12, it is coming as 0.202. So scale is somewhat coming big, 0.202. So I'm just starting it from 0.806. Why? Actually my scale, the value is coming 0.202. If I take 0.202, it's not around 200, the last point, this will not come on the graph. So I can, if I take 4, exactly roots will be followed, but it will not look good. So I'm just starting with the same value 0.8060, and let us see what happens now. Can I get rid of this one? 3.224 minus 0.806 and divided by 12. Still I'm not getting there. It's 0.205. Now 2015, is the value coming. So I will for in these cases, now it's up to you. I can take 0.25 the scale. Then it's okay if you start from 0.8 in either. So take 0.25 scale and at 0.8, this one 0.8 plus 0.25. See, I'm again going to make, I just tried if I started with this one, whether I can get rid of it. I'm not getting rid of that one. So what again, I'm going with this one because then it will be easy, numbers will be easy to handle. So I start from this one, 0.8. So the value comes out 3.224 upon minus 0.8 divided by 12. It comes to 0.202. So this is 202. I cannot take 0.2 because it is, then the last point will not come. So I will take 0.25 after 0.25 the scale. So I am adding 0.8 plus 0.25. It comes 1.05, 1.30, 1.55, 1.80, 2.05, 2.30, 2.55, then 2.80, then 3.05, then 3.30. So these boxes are called 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes. So it's okay. Then I will write here a one value, another value for the small box. This is for 10 boxes. So scale for small box will be 0.025. So this is, I have set the scale. Now I have to plot these points. Let us see how I am plotting these points. I'll just tell you how to plot one or two points. Suppose I am plotting this one, 0.560 and 2.257. First I will go for 0.560. See, the formula for x-axis is reading minus starting, divided for x-axis you have to divide by this number. It is written here for you 0.01. Just, you do not write down this paper, just this formula in mind. What's my reading? My reading is 0.560, 0.560 minus what is starting, 0.2 and divided by 0.01. I get 36 boxes. So this is 10, 20, 30, 36 boxes will be up to here. So I will go for this one, 36 boxes. Then this is 2.257. So it will be 2.257 minus 0.8 divided by 0.025. Number of boxes will come 2.257 minus 0.8 divided by 0.025. It is coming 58.28. 58.28. I will ignore this. Only 58 small boxes I will count from here. 58 is 10, 20, 30, 40, 50. 50 and 58. 1, 2, 3, 4. This will come here. I'll just point this one, not blob. I'm just making so that it can appear on the video. So this point is here, this one, and this one inside it. So this is the point. Similar way, suppose take another example. I'm just plotting 2 points. I'm taking this one and this one. Now how I will plot 0.440 on first on x-axis. I will just write 0. On calculate 0.440 minus 0.200 divided by 0.01. But I get 0.44 minus 0.2 divided by 0.01. I get 24 boxes. This is 10, 20, 24 boxes will be here. 24 boxes somewhere here. Now it is 1.773. So 1.773 minus 0.8 divided by 0. This written here. You do not need to write this one on the paper. Just you can use this for calculation directly. Minus 0.8 and divided by 0.025, and it comes out to be 38.92. So I will take 39 boxes. 10, 20, 30, 40, 39 voxels are here, this point. They are coming in a straight line. So I will always go for this thing. So in that way, always you can point the things. So I'm not pointing other points, because in this I'll be just doing these practicals completely. When I'll be doing completely, I'll be plotting all those on the actual graph paper. So just wanted to make you know how this pointing is done, how this plotting of the points is done. So this was the case. Now when the points are plotted, how we will draw the line of best fit. Now comes the line of best fit. How the line of best fit is drawn, what should be qualities. First of all, we have not taken that origin. Some teachers say it should pass always through the, that's not the stuff here. Okay, we cannot say it should pass through the origin. Now you cannot forcefully pass any line to the origin or the false origin. So first of all, always I tell you first thing is, what are the characteristics of the line of best fit? It must be drawn with one stroke only. One stroke. Do not take two strokes. With one stroke only. For that you should use the 30 centimeter. You can use 30 centimeter transparent rule comes. 30 centimeter transparent rule, and use this one to draw it through one scale, one stroke. If you do not draw it one stroke, what happens? If you draw it with a smaller scale, then first you draw up to here, then the scale is tilted, and then line becomes this one. So there is a tilt is here. This becomes a kinked line, which is not allowed. So kinked line is not allowed. Draw it with the one stroke. And second thing is, always draw it with very thin pencil. Use very thin pencil to draw it. Pencil must be sharpened first, then you can use it with very thin pencil to draw it. The line should not be hairy. Although it's very funny to say, by hairy line what we mean like this one. Suppose how the hairy line is made. Sometimes the students use eraser so many times. Suppose this is the line drawn, but it appears sometime here, this one. These appear as hair on the line. So the line must not be hairy, and this will actually, so that line is not kinked. So no kinked line, no hairy line, and always there must be the equal distribution of the points. Equal distribution of the points. Equal distribution of points on both sides. In some cases, difference of 1 point is allowed. Suppose it's not possible to have the proper distribution on both sides, then a difference of 1 point is allowed. Now let us see how I can draw the line of best fit. This is the line of best fit, because you can see 1 point is up the line and 1 is down the point. This can be the line of best fit. It's not kinked, it's 1. You can say, suppose even one difference of 1 point is allowed. So if this is point, other point can be here, this one. There's a 1 point up and 0 point. So difference of 1 point is allowed, or it can be here also. Difference of 1 point is allowed. So I can always say that always the distribution must be proper. Even it can happen, none of the points is on the line. You can see, none of the points is on the line. none of the points of the line, but it's the line of the best fit. 3 points up and 3 points down, so that the average is the same line. So these type, in this way, you can always draw the line of best fit. Line of best fit must have 3 properties. First, it should be with 1 stroke, or it should not be kinked. Other thing is, it must be with very thin pencil, and the third thing is, it must not be a hairy line, and always it should not come out of the margin of the graph paper. You are not allowed to draw the line out of the ground. It should not be forcibly passing through the origin at some point. So this is the line of the best fit. Now, how the gradient is being calculated? Let us go for the gradient and significant figures in gradient. First of all, gradient is always calculated by delta y upon delta x, change in y upon change in x. So, and how many significant figures in gradient will be? We will see the least number of significant figures in y-axis or x-axis should be in the gradient. For example, suppose delta y or y-axis has 4 significant figures, roughly 4 or 3, 4. Suppose some values are on 4, some values are on 3. So I will suppose 4 significant figures. Suppose some are 4 and some are 3. 4 significant figures. These are suppose 3 significant figures. So I will take the gradient in 3 significant figures. So it is, but as a rule of thumb is, usually take the gradient in 3 significant figures. Usually take the gradient in 3 significant figures, and I tell you, gradient has no units. Actually, you are not taking the units, those are the pure numbers, because you have just, suppose if you take in L oblique meters here, and if this is suppose 0.200, it is actually like this one. This is a pure number. So pure numbers do not have the units. Meter comes here. So pure numbers do not have the units, so gradient has no units, so do not write the units of the gradient. Although the examiners are very much reluctant about this, if you write the unit, you will not lose your marks, but it is better not to write the units. So let us see how the gradient is being calculated. First of all, please, examiners actually do not give priority for the formula y2 minus 5 upon x2 minus x1, the usual traditional formula. But first of all, I tell you, always select a point which is at top of the line and passes through exactly from corner of a box. It must be passing through the corner of the box. Then select another point at the bottom of the line. Select another point at bottom of the line which also must pass through exactly passes through exactly from corner of the box. Then always draw the triangle. Always draw the right angle triangle. Right angle triangle. Now suppose if the line is like this one, I will select at one point at the top which is passes like this in a small box, this is the box, it's completely boxing, and I will select here another box, suppose like this one. This is the box of the graph. So I will select these 2 points. Now I will draw a triangle over here. This one. Right angle triangle. I will indicate the triangle on the graph paper. Actually, there's always the examiners give the marks when the triangle is indicated on the graph. So a triangle will be indicated on the graph, and I will count these boxes. This is the delta y. These I will count the boxes. Suppose these boxes are suppose they are coming as 81 boxes, small boxes, delta y. And I will write 81 boxes. And here I will not suppose delta y. Suppose 49 boxes. So now what is the gradient? This delta x, sorry. So gradient will be equal to 81 box multiplied by, this will be scale of one small box along y-axis divided by 49 into scale of one small box along x-axis. So suppose my scale is 81, my scale is 0.025, small box. 49 into, I will take suppose 0.01. So this will be the gradient, and this is the positive gradient. See how the positive gradient, if we go through the triangle, this is right, so x is positive, and up, so up is positive. I tell you, x, this is positive. If you go in this way, this will be negative. This is positive. If you go in this way, this is negative. So you can always have the signs like this one, then the gradient. Or another thing, if the line is this is positive gradient. Take directly. And if the line is like this one, this is the negative gradient. Takes negative gradient. So if this is the positive gradient and this is the negative gradient, so this is the clearly positive gradient, I will take this one and I will calculate whatever the things come, that will be the gradient. I don't mind whatever the calculation comes out to be. It should be in 3 significant figures. So this will be the gradient. Now suppose if it is a negative line, then how the gradient you will make? How the gradient will be calculated? And gradient, you have to usually gradient is in 3 significant figures. Suppose the line is like this one, and suppose this point is, this is the corner of the endpoint, this box. I am making this one. This one. Suppose here are 60 boxes and here are suppose 90 boxes. Supposing. Scale of one small box is here is suppose 0.02, here is suppose 0.01. So what should the gradient? I will say gradient will be, I will show the triangle, this one. The triangle is very big. It is a very large triangle. The requirement is it must be a very large triangle. So delta y will be, these are 9, this must be gradient minus, I will take minus sign directly here. And 90 into 0.01 upon 60 into 0.02. Actually these are 90 boxes, means its actual value is 90 into 0.01. These are 60 boxes, actual value is 60 into 0.02. And if 10's power is along the y-axis, you can always take that also in one of the calculations of delta y. Either this way, or you can say take this one. Now this is down, so this must be negative. You can take it this way, and this is positive, take this positive, and all our result will be negative and calculate. That's the gradient. Now how to calculate the y-intercept? Now we usually, in most of the cases, we do not start graph from the origin. So when we do not start graph from the origin, if the graph is being started from the origin, then you can read y-axis, okay, the y-intercept. But in majority of the cases, we do not start from the graph from the origin. Then how we calculate the y-intercept and how many significant figure it must have? Always keep in mind, y-intercept must have the least number of significant figures along y-axis or x-axis. But as the rule is, you can take usually 3 significant figures and y-intercept is down. Your answer should not exceed by 3 significant figures in the y-intercept. And for the y-intercept, always use this one, y is equal to mx plus c. And first of all, see, you should have calculated gradient. Suppose the gradient is coming 0.402. So I will write this equation y is equal to 0.402x plus c. But suppose the gradient is negative, suppose the gradient comes this one, minus 0.402. So I will write then minus 0.402x plus c. Then I will look for the point x, y. I will look that point which lies on the line. Which lies on the line. I will always look at the point which lies on the line, and preferable. I will prefer a point which is on the line and in the table. But care must be taken in this one. For example, suppose I have to find a y-intercept of some point like this one. Suppose this is the line and its gradient comes out to be, suppose, 0.402. Now I am seeing this is the line of ascent. Now I see, I will select either this point or this point which is on the table and which is on the line. I will select this point and this point. But see, you can take another point. Suppose you can take this point also, this point also. But why I am taking these 2 points? Because they have been already in the table and you can recognize them x and y axis, whatever it is the case. So it is very easy to put either this point in this formula, y is equal to mx plus c. Then you can calculate. But care must be taken. Sometimes what happens, suppose this was the point, this one, supposing this is 0.200, exactly at 0.200 coming, supposing, and this point is suppose 0.006. I am supposing these values are on x-axis and this is on suppose y-axis 0.02. So if this the point is 0.006, 0.200. Now this on the graph is 0.20, but suppose in the table this was the point. Now when you plotted it, you plotted 0.200 and in the table this was. So now this is on the line and this is in the table, although it appears to be same. So I will take this one on the line. I will not take this one. I will not take this point. I will take that point, this one, which is on the line, because I had to find the y-intercept of the line. So I will write just y is equal to 0.402x plus c. I will take this point 0.006, 0.196, or even this can be changed. So I will always take the change value, but it should be, so I will say do not even go for the point on the table, always go for the point which is on the line. And if you put this here, this was 0.196, so 0.402 into 0.006 plus c, and calculate c whatever comes. I'm sorry. So that will be the calculation of y-intercept, and y-intercept will always be in 3 significant figures. Again, suppose if the gradient is negative, then you have to write this minus 0.402x plus c. Usually the mistake done by the students is in the negative gradient, if the line is like this one, negative gradient, they actually take the sign of the gradient, but then they forget to take the sign of the negative sign for finding the y-intercept. It's very much essential to take that sign also.